The old asteroid on the end of a rope idea has gone the way of carriages drawn by horses. Once the modern-day space elevator emerged in 2020, the concept of an active transportation node at the apex anchor became obvious. The enhancement of the roles at an apex anchor showed how it will become a full-service transportation node for several significant missions centered around the logistics center at the top of the gravity well. Likewise, the concept of sending goods into space using space rockets will remain in the past, since they can only transport small loads per trip, and to make matters worse, they are extremely polluting and do not represent in the least the ecological concept of green road to space that represents the 100% functional structure of the space elevators. In short, it would be comparing a small ferry that has a limited number of cargo for each trip it makes on a huge river, with a huge bridge that connects both banks where that ferry operates. Before starting, we are going to highlight the importance of having a space elevator working at 100%, comparing each element separately with elements that already exist and that form a successful transportation set here on Earth. Important note: to get an idea of dimensions, keep in mind that all astronauts are 2 meters tall. A road with a tether. Currently, to carry goods over long distances, we need roads, in the same way the road that unites all the elements of the space elevator is the tether. A road 100,000 kilometers long. Trucks with a climber. Normally, all merchandise is transported in trucks, which carry containers and travel the previously mentioned roads. The climber is our truck, with the difference that it is very ecological since it will be electric. For more information, I leave you here and in the description 2 videos that explain everything about climbers. Local distribution points and node in geo. To distribute this merchandise at the level of a region, distribution centers are needed. In the same way, when the climber arrives at geo, it will be able to distribute merchandise to future constructions close to the Earth such as solar farms, L5 space colony, etc. Ports with apex anchor. But if you want to take merchandise to other countries, the perfect place is a maritime port. From there you can store containers, repair ships, rest place. Communications and coordination. Customs, in the same way, will be a 100% developed apex anchor with the difference that it will send goods to our moon, Mars or any planet in our solar system. In short, all the components mentioned that make up a space elevator with the exception of the climber are permanent and reliable space infrastructures that would be in space, and the climber is the vehicle that travels, carries and brings goods to and from space. First we will start with the infrastructure in the apex anchor, docking station for spacecraft destined for the Moon, Mars and beyond. This also serves for repairs if necessary and for assembling ships or satellites on site. Robotic arms that help accommodate containers inside spacecraft. large number of solar panels, which will power the entire infrastructure. Inflatable habitats that will house the astronauts who work in the Apex Anchor, will also accommodate those who are in transit to other planets. It also has an astronaut rescue preparation area with material necessary for rescue, and communications infrastructure, and also asteroid detection potentially dangerous for the Earth. Dream Chaser-type ships that bring and take astronauts to space missions and the personnel who work at the Apex Anchor. Large storage capacity for containers that come and go from space or store refractions for spacecraft or future bases in space. Robots that are capable of unloading the containers from the climber and arranging them in the container warehouses. They are also capable of taking them to the top where the ships are prepared for their missions, repairs or assembly. Electric climber, which travels from GEO to the Apex Anchor and can carry up to 12 large containers. Important note: in this presentation, we will assume that all the components of a space elevator are already finished and fully operational. We will also assume that its anchorage on Earth is close to the geographic equator, specifically in the territorial Sea of Panama. One of the most important characteristics to highlight of the Apex Anchor is taking advantage of its location, since, at kilometer 100,000, the speed at which the Apex Anchor moves is 28,000 km per hour, 17,400 miles per hour. At that speed and with a slight boost, spacecraft could reach the Moon in just 14 hours. And sending missions to the planet Mars would take months to reach that planet, and not years as is currently planned. It should be remembered that the rocket will take off, empty, from Earth and upon reaching the Apex Anchor. Everything necessary to the mission would previously be waiting to be loaded onto the rocket, including refueling the rocket. Let's imagine a cislunar mission either to a station in orbit or a station on the surface of the Moon. For this example, we will use a lunar prototype from the movie 2001, A Space Odyssey, the ship, Mobius Ares 1B, which is currently docked to the Apex Anchor and is being carried by the astronauts who will travel to the Moon. Important note: this ship was assembled at the Apex Anchor and never lands on Earth. Its purpose is to travel to the Moon and the Apex Anchor. Once the spacecraft is loaded with goods and supplies, with the simple act of undocking and with a slight boost from the thrusters, in about 14 hours of travel to the Moon, it would be docking at an orbital station or descending at a base located on the surface. Important note: in this representation, the exact moment for the launch had to be previously calculated and the destination hit, since the equatorial plane of the Earth varies throughout the year. If the launch is earlier or later, the chances of hitting the programmed destination are reduced and you will have to spend a lot of fuel to correct the trajectory or worse. The same would happen with trips to Mars, once the astronauts of the mission themselves load the supplies they will need for their successful performance on Mars. They will only have to undock from the apex anchor, and with slight impulses from the thrusters in a matter of months they will reach Mars. Space elevator infrastructure will be compatible with rocket launch infrastructure and complementary in supporting the mission. This is because advanced rockets take people through radiation belts quickly without endangering them. And space elevators handle heavy mass lifting on the green route to Mars. SpaceX has declared the need for 1 million tons of supplies on the surface of Mars. When the galactic ports are mature, more than 150,000 tons per year will be released into GEO and beyond, less than 7 years once started in late 2030. Helping the SpaceX company to send these quantities of 1 million ton to Mars does not sound so far-fetched if you take into account that the final goal of space elevators is to create a minimum of 3 of these structures at various points of the equatorial line, so that in this way they compete loyally and in harmony, sending cargo in a coordinated manner to space. As previously said in this video, the distribution node would be in GEO. At this important point the load that will continue its journey to the apex anchor is determined, or is directed to infrastructure in other constructions in GEO or LEO around the Earth. This distribution node also has inflatable habitats, Dreamchaser-type ships, rescue equipment, telecommunications, loading and unloading robot, warehouse. It will be very similar to the apex anchor. Likewise, all merchandise that travels from the apex anchor to Earth passes through this point. Although it has a warehouse, they will not be so large, since this is only a transit point for the merchandise. In GEO, at a distance of about 1,000 kilometers from this GEO distribution center, a huge solar farm will be located. When it is finished and 100% functional, from there the energy will be collected and can be sent to the climbers by means of laser or microwave, both the climber that travels from Earth to GEO and the one that travels from GEO to the apex anchor. Even the solar farm, when 100% functional, will send energy to the apex anchor, and will supply energy in its entirety, the habitat and all the facilities, both those of GEO and those of the apex anchor. Important note: if possible, a second climber could be included that travels from Earth to GEO. These infrastructure are necessary for the progress of humanity towards the green road to space, and would be an important and firm step to become a Type 1 civilization.